Okay, I'm just going to bring in one more thing, even though about the perinatal environment. It's going to come back a little later. Angela Favaro has published some very interesting data suggesting that for anorexia nervosa, a range of perinatal risks and complications are associated with something like 2 to 5 times higher risk of anorexia nervosa. Somewhat the same is true for bulimia nervosa, although a little less strikingly. And that'll come back in a minute. Okay? So while we're talking about physical risks, let's think of heredity for a moment. Are eating disorders hereditary? Now, of course, you're going to look at twin studies to establish that. For anorexia nervosa, you know when you apply ACE models to establish genetic influences versus shared environmental influences versus unique environmental influences, the data are very striking. Shared environment, like being in the same family, 0. Unique environment usually accounts for something like 50% of a variance, like being subject to a developmental abuse versus not. But you can see that, what you're seeing there is the coefficients for heritability for the genetic effect. Somewhere around 50% or more of anorexia concordance in twins is attributable to genetics. Bulimia, kind of the same thing. Binge eating disorder, a little bit less so maybe, but the same thing. So these are clearly hereditary conditions. They have a heritability. And we're starting to look into kind of what specific genes and gene polymorphisms might be associated with this transmission. What most people have been looking at is main neurotransmitter systems that would be involved. Dopamine, for example, we've just been hearing a lot about it. Motoric behavior, reward, certainly is involved in the reward properties of food and that sort of a thing. Impulse control to a certain extent as well. So there's a lot of interest in seeing, do genes that influence dopamine activity have a role to play? Serotonin, guaranteed to be a player. What's it affect? Mood, anxiety, impulse control, social behavior, and satiety. So it's a likely candidate. We're talking about disorders that affect mainly women, estrogen. Various other genes that particularly act on appetite regulation, metabolism, and so on have been explored. BDNF, for example, brain-derived neurotropic factor. Not only is it associated with neuroplasticity, it's involved in appetite suppression, weight suppression. Where you're seeing AN or BN, you have some semblance of evidence to suggest an association with eating disorders, okay? Not to say that any one of these genes is going to cause a complex syndrome like anorexia or bulimia, and clearly they're polygene driven. But complex interactions among these things, may be a little more viable. But I would make the point, and I think it's true for other categorical syndromes, maybe in schizophrenia, maybe in affective disorders, evidence for a broad association of any single polymorphism with any categorical diagnosis is really unimpressive. To make the point, here's a box score count for every study that says, yes, a gene or a polymorphism is associated with anorexia or bulimia. There's one that says no. And so, you can't really get all excited about that. We have a small number of GWAS genome-wide type studies that are accumulating. The early ones, which were based on pretty small samples, suggested weak effects. Maybe chromosome 1 was kind of pointed out as an interesting site. The more recent studies, which have much larger samples, show no effects at all. So again, there's not that much evidence for kind of a direct genetic predictor, leading me to cite my colleague Cindy Bulick in saying genes are innocent until proven guilty. But I'm going to give my own quotable that follows it. The genes may be brought up on different charges, and they're not guilty of causing the anorexia, but maybe they're guilty of other things. And as a case in point, I'm going to show you some data from our lab involving the serotonin transporter promoter and MAOA, a polymorphism that acts on MAOA. Okay, the serotonin transporter, everybody knows we're talking about the thing that does reuptake of serotonin. It regulates activity in the synapse. Low function alleles are associated with reduced transcriptional efficiency, less of the protein that does reuptake, reduced serotonin uptake rates. And it's thought also to have, don't only think of this as meaning more circulating serotonin if you have reduced reuptake. You can think of neurodevelopmental effects that are starting right from the beginning of fetal development that alter brain functioning throughout one's life. In general, in non-eating disordered populations, Low function alleles have been associated with that kind of dysregulatory profile I was talking to you about. Impulsivity, novelty seeking, affective instability, stuff like that. Okay? High functioning alleles are associated with the converse to some extent. Compulsivity, obsessive compulsive disorder. There's Heinz and their group suggests evidence of hyperfrontality in people who have too much cortical inhibition in people who have the high functioning allele. Okay, so what do we find? We take a large sample of eating disordered women. This study, I think, had 185 of them. With latent class analysis based on all kinds of psychological scales, we divide them into an impulsive group, a compulsive group, and a group that has low psychopathology on both of those indices. Okay, you with me? You notice the impulsive group, 3.6 times the likelihood of having the low function allele of the serotonin transporter. They're more likely to have that thing that makes you dysregulatory. Compulsivity, more likely to have the high function allele. And in the low psychopathology group, you don't see any difference at all. So you're sort of seeing at a genetic level, perhaps, that kind of idea also of the two-component model. Doesn't explain why you have an eating disorder, but it might shape the expression of the eating disorder in an individual who develops one. MAOA now. Well, okay. Just very quickly. You probably know MAOA activity, which presumably you're talking about more breakdown of serotonin, is associated with suicidality, postmortem brain tissues. Genetic association studies link the high function MAOA UVNTR allele with impulsivity, suicide, and particularly violent suicide. Here's results from our study in about 400 people. It was a multi-site Canadian-German collaboration. We're measuring SHBs as self-harming behaviors, tendencies towards suicide, self-mutilation, other kind of parasuicidal acts. And people who report higher rates of SHBs, parasuicidal acts, are more likely to be carriers of the high function alleles of the MAOA, as expected from other populations. And you see the same thing in the Canadian women and in the German women. Okay? So, it turned out there was about 2.4 times the risk of a self-harming behavior if you carried at least one high function allele. Okay? So I would try to make the point that genes may correspond more reliably to dimensional traits, impulsivity, compulsivity, self-harming behavior, than they do to categorical things like anorexia and bulimia. And that's what I meant by the other charge that they might be guilty of. Okay. So to account for our kind of three groups, let's think of people who are constitutionally dysregulated. They have genetic tendencies towards dysregulation, as well as perhaps environmental stimuli for that kind of thing. These are people who are more constitutionally overregulated. Over there, I would say that's your kind of everyday person who might diet too much and sets up the eating disorder and has quite a different flavor. You could think that would have different implications for treatment needs, likelihood of recovery, all kinds of stuff. But I still want you to be disappointed. There's nothing that's disorder specific still. We can't say, why did you get an eating disorder? Okay, let's try to get a little more complicated. Gene-environment interactions now. Genetic potentials get switched on by the environment. I guess you know all the paradigms, right? You peer rear a monkey rather than rearing it with its mom. That's a stressor for a monkey. It would be a stressor for anybody, I suppose. Those who carry the low function allele of the rhesus version of the serotonin transporter show altered serotonin function as adults, fearfulness, more alcohol consumption. Steve Sumi has a study that suggests these are monkeys that are prone to compulsive or binge-like eating. Okay, and in humans, we have exact parallels to those same gene-environment interactions. Stressed carriers of the low-function serotonin transporter promoter alleles, stressed by childhood trauma, combat exposure, things like that, involvement in accidents, are more depressed, more anxious, more substance abusing, prone to disinhibition or impulsivity, and according to our studies and Andreas Karwatz's study, more anorexic and bulimic. Okay, so let me show you the bulimia equivalent of some of these interactions. Here's a group of about 92 bulimic women. We've divided them into those who report clear-cut developmental abuse. They're severely sexually abused in childhood. They're severely beaten physically. Now we see them as adults. or those who deny such abuses. And what you're seeing there in the blue bars is those who do not carry this low function vulnerability allele. Red bars, those who do, on a measure of stimulus seeking, novelty seeking behavior, impulsive, reckless seeking out of new stimulation. Maybe a little bit like people who are prone to substance abuse. And you get a significant interaction effect. The combination of the low function allele with abuse is more likely to be associated with the expression of that trait. Same is true on a measure of what we call dissocial behavior. It's a scale derived from the, well, I won't go into the details. If you want to know, I'll tell you after. It reflects a kind of conduct disordered, impulsive, hostile, slightly borderline kind of flavor. And again, you see the same type of interaction. If you've been abused and you carry the allele for vulnerability, you have more of that trait. Disorder specific, still not. It'll explain why you might be impulsive or reckless. Doesn't answer the question, why did you get an eating disorder? So, how can we explain why you get an eating disorder? What's another thing? If you wanted to mess up your serotonin system as best as you could, what would you do? Sorry? Just eat steak. Well, that's not a bad idea. Or go on a diet, right? Anybody in this room do a modest diet for about 3 weeks?
No one will let you do that.
Well, no, I mean, unless you all put up your hands, you're not honest. But the point is that Cal and Anderson and the group out of Oxford have some very nice data that show that pretty modest dieting will cause substantial alterations in serotonin function. And particularly that effect is more powerful in women. So sorry, ladies, you are more susceptible to the effects of dieting than... I always say, I direct what I call the church of non-restraint. We'll talk about that later, but I'm a big no more dieting fan. But that's a whole other story. But certainly one factor that might explain what tips the risk of eating disorders more in a female direction as well. So